Hi class, and welcome to problem number 3 on our notes, which is 6.8 notes day 1. We're doing quadratic word problems. What I want you guys to do is I want you to try number 3 on your own. After trying number 1 and number 2 with me, hopefully you got a little feel about how these problems work, and I want you to pause the video and try number 3. Try as best you can to get all those on your own, and then check your work with mine after you're all done. So as you can see, here's this baseball player. And he hit the ball, and the equation that he hit this ball at is 0.005 x squared plus x plus 3. This gives the path of the ball, where h is the height of the ball, and x is the horizontal distance the ball travels. So if we kind of look at this problem and try to make sense out of it, he hits it from a height of 3 feet above the ground. So I would say that would be right at about his waist, right at his belt buckle, I suppose, is where this fastball came in at, and he hit the ball. And here is how he hit it, where h is how high the ball went. So up and down, how high did he hit this ball? And x is the horizontal distance, so how far did he hit the ball? Did he hit just a weak line drive? Did he hit it a deep bomb? That's kind of what we're talking about with our x variable. That gives the horizontal distance. So letter A, what is the maximum height the ball reaches? So when he hit it, baseballs travel like this generally, right? So our parabola looks something like that. What is this maximum height? As you found out from problems number 1 and problem number 2, that's our vertex. So let's find our vertex. Our axis of symmetry is a negative b over 2 times a, which is a negative 0.005. So we might have to do some calculating here with our calculator. 2 times a negative 0.005. 2 times negative 0.005 is a negative 0.01. Negative 0.01. So now we have a negative 1 divided by a negative 0.001. And then a negative divided by a negative is a positive, and a negative 1 divided by a negative 0.01 is 100. So my x equals 100. I added in too many zeros here, didn't I? 0.01, and that equals 100. So what is the maximum height of the ball? My x equals 100. However, I don't want to find x. I don't want to find the horizontal distance. This is 100 feet away from home plate. I don't want to find that horizontal distance. I want to find how high that ball went at 100 feet. So the height I find by substituting. So 100 is going to go into x squared and into x. So we have a negative 0.005 times 100 squared plus 100 plus 3. When you put this into your calculator, I trust that you did this on your own, you got where are we at here? 53 feet. 53 feet is my y value, or actually my h value. H equals 50, not doing too well here. H equals 53 feet. So when my horizontal distance is 100, my vertical distance, or my height, is 53. So that answers problem number 8. What is the maximum height of the ball? It is 53 feet. An outfielder catches the ball 3 feet above the ground. So here's our outfielder way over here. And he catches it, so I suppose he catches the ball. He didn't catch it above his head. He didn't catch it down by his feet. He caught it 3 feet above the ground, so I suppose right at about his hip. How far has the ball traveled when the outfielder catches it? So in my equation, which is h equals a negative 0.005 x squared plus x plus 3. The outfielder catches the ball 3 feet above the ground. So the height that he caught it at is 3. So h equals 3. find x. Find how far the ball traveled, which is that horizontal distance. So we want to get x all by itself. So when h equals 3, a negative 0.005 x squared plus x plus 3, we have to find what x is. So when we subtract 3 here, we subtract 3 here, it's gone. So 0 equals a negative 0.005 x squared plus x. So now that we're to here, we want to get x all by itself. Here's two different terms. They both have an x in it. So I'm going to take my next step and I'm going to factor out an x. So I now have 0 equals, I factored out an x, and now I'm left with a negative 0.005x, a negative 0.005x, and I'm left with, after I took this x out, I'm just left with a positive 1 right there. So plus 1. Those two factors I set equal to 0. So x equals 0 is this one, and a negative 0.005x plus 1 also equals 0. So this is the one that I'm going to find. We already know that my vertical or my horizontal distance is 0 feet when the height is 3 feet off the ground, because that's where he hit it from. But now after it had traveled a distance and an outfielder caught it 3 feet above the ground, how far is that distance? Which is going to be found by solving this one. So I'm first going to subtract the 1. So a negative 0.005x equals a negative 1. And now I'm going to divide by a negative 0.005. So a negative 1 divided by a negative 0.005. A negative 1 divided by a negative 0.005 is 200 feet. 200 feet is my answer for letter B. X equals 200 feet. So this ball got hit at a 45-degree angle. It reached a height of 53 feet high and a height or a distance of 100 feet in length, and then it kept on going until it was caught at 200 feet when an outfielder caught it 3 feet above the ground. So that is problem letter B. It is a height or a distance of 200 feet. And now problem letter C. If the outfielder misses the ball, so evidently he misjudged it or dropped it or whatever, how far will the ball have traveled before it reaches the ground? So think of this for a second here, class. Here's our parabola. It was hit from home plate. Hit from home plate. A guy should have caught it 3 feet above the ground, which is right here, but evidently he missed it, and so now it's going to fall that extra 3 feet, and it's going to hit the ground right about there. So it says, how far will the ball have traveled before it reaches the ground? So now, what is this distance? We already know what this distance is. This distance is 200 feet. So if you're kind of thinking critically here, the ball went past our outfielder, but not by much, I don't suppose, because it's just 3 feet lower, the ground is. So it might be like 205 feet, 210 feet, maybe just 201 feet. It should be more than 200, but probably not too much more. So I want to find this vertical distance, which is x, right, when my height is the ground, which my height is 0 feet. So going back to my equation of my height equals a negative 0.005 x squared plus an x plus 3. I want to find what my x value is when my height is the ground, or when my height is 0. So let's just take this off and put a 0 here. All right, there are several different ways that I taught you to solve for x. The easiest way would be factoring. Stink, this one cannot be factored. I would say the second easiest one would be the quadratic formula. So let's get x all by itself by using the quadratic formula. So write with me, please. We have a equals a negative 0.005, b equals 1, and c equals 3. So we have a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. It's going to get a little bit messy. That's what calculators are for. Let's first solve our discriminant. So a negative 4 times a negative 0.005 times 3. A negative 4 times a negative 0.005 times 3. We get 0.06. So this whole thing right here is 0.06. And then we also have this 1 squared with this 0.06. So 1 plus 0.06 is 1.06. So now we have a negative 1 plus or minus the square root of 1.06 divided by 2 times a negative 0.005. 2 times a negative 0.005 divided by a negative 0.01. Negative 0.01. So we kind of get two different answers in this one, don't we, class? We have a negative 1 plus the square root of 1.06 divided by a negative 0.01. And we also have a negative 1 minus the square root of 1.06 divided by a negative 0.01. Put both of those in your calculator, and we will get two different values. When we put these in our calculator, the first one, we get approximately a negative 2.96. Is there any such thing as the ball going a negative 2.96 feet? No, this one is not possible because there's no such thing as a negative distance. So our answer must lie in this one. And remember, we should get somewhere around 200 feet, a little bit more than that. So if we do this one, we get approximately 202.96 feet. And that looks more like it. We know that if the outfielder were to catch it at 3 feet off the ground, the ball would have traveled 200 feet. If he missed it, it would go behind him, and now the ball would travel even further, about 3 feet further, at about 203 feet, or 202.96. So that's a little bit about how parabolas and how quadratic equations really affect our daily life. In tomorrow's lesson, we're going to use our calculator to do more precise measurements, as well as even more abstract things that are used quite often in professions such as in, aircraft and a lot of professions that have to deal with the physics aspect of things. So get ready for that tomorrow.